My name is Lillian Jones, and my final project for junior design is Who Fed Yugi, which is a Bluetooth pet feeder using the ATmega 328P. My inspiration for this project came from wanting to create a simpler, easier way to feed my cat Yugi. It always seems like it's hard to get somebody to feed the cat other than myself, so I figured why not make it easier for my roommates? There were a few requirements that I wanted the design to have. I needed to have the design deliver precise portion sizes upon each feeding. I wanted the software UI to keep an accurate log of recent feeding times and portions. I wanted it to be Bluetooth connected so that the user could access it from their own computer. I wanted a simple, user-friendly UI for the main device. I needed the circuit to be small and compact to be able to fit onto the feeder, and I needed to create an enclosure for the circuitry. After I had determined all the requirements for my project, it was time to lay out a preliminary design. First, I wanted to design a software UI for the main program using Qt Designer. I then planned to add backend functionality to the UI using Python, as Qt Designer projects can easily be integrated with the language. I knew that on the UI, I wanted to display a feeding log of who had last fed the cat, how much the cat had been fed, as well as other information like the date and the time. However, I did not want this log to reset every single time that the program was ran, and I wanted to keep its state between instances of the program. I also wanted the log to be the same for every device that it was on. Therefore, I knew I needed to utilize some form of cloud storage, so I decided to use the Google Cloud Storage API to create this stateful feeding log. I also knew that I would need to create an original PCB and enclosure for the design. However, I needed the main device to communicate with some form of hardware that would be on the feeder itself. Therefore, I plan to create hardware circuitry using the ATmega 328P. In this circuit, I would use the HC05 Bluetooth module to connect from the main device to the circuitry via Bluetooth. Then I connected the I2C LCD screen to display the feeding state as well as other important messages on the feeder itself. Then I would configure a servo motor to actually dispense the food. Before actually designing and soldering a PCB, I needed to test my preliminary design. I first decided to do this within the main program, and I gradually tested it as more and more features and components were added. The first feature that I added, after creating the UI, was configuring the Google Cloud Storage API. I tested that I had done this correctly by appending data to a spreadsheet in my program and uploading it to the cloud. I then checked the data that was uploaded to the cloud to make sure that this was done correctly. Then I needed to test that my main program would be able to send data to the HC05 Bluetooth module. This is done very similar, if not actually, through serial communication. Therefore, I created a serial object within my main program to send data from the main program to the hardware. In order to test this, I sent a character from the main program to the ATmega using the HC05 Bluetooth module. At this point in the testing process, I also connected my LCD screen. Therefore, I sent a character from the main program to the ATmega, and the LCD screen would display a specific message depending on the character received. I tested this to make sure that the correct data was being sent. Then, it was time to test the rest of my hardware. Several different breadboard tests were conducted as more components were added to the prototype. I also added a button so that if the user wished to activate the feeder directly from the feeder, they would be able to do this in an easy way. Video demonstrations of all of these tests are outlined in the report. Finally, I added the servo motor and conducted tests regarding that. I began with a continuous rotation servo motor, but later had to replace this with a more traditional servo motor to get it to work with the rest of my hardware implementation. Photos of the final breadboard prototype can be seen here, and videos of this are referenced at the end of the presentation as well as in my report. On the left, you can see a photo of the entire breadboard design. You can also see on the right a photo of the LCD display as well as the servo motor being secured to the table to be able to observe its motion through testing. After creating a breadboard prototype, it was time to implement my design in a more permanent way. Components were all configured in the breadboard testing phase, so it was time to solder them. Due to time restrictions, I did not create or solder an actual printed circuit board. However, I utilized many smaller perf boards and soldered these and connected them in order to implement my design. Then it was time to create an enclosure. I did this through using a small box and cutting holes to display each of the different components where they needed to be. Then I fixed this onto the side of a cereal dispenser so that the servo motor would be able to turn the arm and dispense the food during the interval desired. Several pictures at this stage in the design can be viewed here. On the left side, we see several of the different perf boards that were soldered and later connected in order to complete the circuit of the design. Then, on the right, you can see the enclosure before actually being sealed. This includes the soldered perf boards as well as the small box with several different holes cut in to expose the components where they needed to be. In the final iteration of my design, the design worked entirely as desired and no portion of the system was non-functional. The main application can be installed and executed on any Windows device with the proper libraries and Python installed. When the UI is displayed, the user can select their name from a predefined drop-down menu and select the amount of food that they wish to dispense to the feeder. Upon selecting the amount of food desired, the feeding instance is added to the feeding log for future reference. Also, when selected, the main program sends data via serial communication to the HC05 Bluetooth module. This allows food to be dispensed depending on the data that is received from the main program. Messages outlining feeding status are displayed on the LCD screen. Changes that I would have made to my design if more time was allowed is that the design is too low to the ground to actually allow the cat to eat from the bowl. Therefore, I would mount my design on the wall and attach pipe to the wall so that the food can travel down the pipe and be dispensed into the bowl itself. On this slide, you can see the final software and hardware implementations. On the left, you can see the final polished user interface. On the right, the final hardware design, powered and connected to the cereal dispenser, can be viewed. Here is an image taken from the final demonstration of the project. As you can see, the UI is displayed on the computer, and the feeder is connected to it. As you can see here, all video links related to testing instances as well as the final demonstration are listed on the last slide of this presentation as well as embedded within the report. Thank you.